Good morning, scholars. First off, I hope that you are staying warm and navigating this winter weather nicely. This video is going to take us through section 6.4, dealing with simplifying all kinds of roots. We're going to go beyond the square root and simplify roots that involve third roots, fourth roots, so on and so forth. So before we get into that, we're going to quickly review how to simplify a basic square root. We're going to simplify a basic square root. So look at example 1, square root of 24. Obviously, if you don't have a perfect square, then we break the square root into two parts. We find two numbers that multiply to 24, one of them being a perfect square. So 24 we can break up into 4 and 6. Then after you do that, take the square root of both parts. So you have 2 square root 6. So remember, the perfect square always goes on the outside. Perfect square always goes on the outside. Now, if you look at examples 2 and 3, now we have variables included with it. So when we're dealing with variables, you have to understand that a square root, since it's a square root, there's an imaginary 2 sitting outside to indicate to you that it is a square root. So there is an imaginary 2 sitting outside of that radical. Now, for the number, it doesn't affect anything. So we're going to take this and separate it. So this is square root 81, square root y to the 4th, square root z to the 10th. Best way to understand it is to see it separated. Square root of 81, that's a perfect square. That's easy enough. That's 9. To deal with variables, you use that understood 2 that's outside. So what you do is you take the exponent that's inside the radical and you divide it by that index. So in the case of y, that's 4 divided by 2, which would be 2. And for the z, that's 10 divided by 2, which is 5. So 9 y to the second and z to the 5th power. So very simple. Even with the variables in there, very simple to work with. Example 3 would work the same way. So first, take the problem and separate it. So 56 is not a perfect square, so that's fine. That's 4 times 14. 2 square root of 14. Set that off to the side. So this is 3 divided by 2. Now 3 divided by 2 doesn't work evenly. 3 divided by 2, 2 goes into 3 one time, but you would have 1 remainder. So since it works out that way, 2 goes into 3 one time, so you would have p square root of p. So anytime you have something that's a remainder, it goes back underneath the square root. Remainders go back underneath the square root. As far as the q's go, 2 goes into 6 3 times, so that's q to the 3rd power. So if you notice, you've got a lot of terms just sitting there. You have some that are outside the square root and you have some that are inside the square root. So when you write your final answer, everything that was outside stays outside. So that's 2p q to the 3rd. Anything that was underneath the square root stays underneath the square root. And there you have it. So using just basic square roots, we can go through the process of simplifying a radical expression. Not anything overly difficult, just knowing the technique and how to work around it. So let's take this one step further. What we just did with square roots, we can essentially do with any kind of root, depending on what it is. So we have x to the third, x to the fourth, x to the fifth, so on and so forth. What we just did with square roots, we do with any root. It's just identifying how to make it work. So the part where the number 2 was, that is known as the index. So the index indicates to you what kind of root you have. The portion underneath the radical sign, that's the radicand. So radicand is what you're breaking down. Now, there's a few key points to keep in mind. Don't have a number outside, it's understood to be a 2, it makes it a square root. Anytime sitting out there, then you need to put plus or minus when you are simplifying it. You have a number, simplified as much as possible, but when you have an expression, when you have variables, you divide the exponents. And complex and imaginary numbers still apply. Complex and imaginary numbers still apply. In other words, if you take the square root of a negative number, you still end up having to put I into the problem. And that wouldn't just occur with square roots. Any even number could potentially come up. So just keep that in mind. So with that being said, let's actually go through the process of simplifying nth root expressions, knowing that some of these are going to travel beyond the regular square root. So start right off with example 1. We have the third root of 125 p to the 9th power. So since you have a number and a variable, we're going to go ahead and separate it just for clarity's sake. So third root of 125 means what to the third power will give you 125. So that's 5. 5 times 5 is 25, times 5 is 125. Third root of p to the 9th, so remember that's p to the 9 divided by 3. So that's p to the third power. And that's it. Just like that, problem's over. Just like that, all finished. So numbers, you treat it normally would. Expressions, you just divide the exponents. So problem 2, you have the opposite of the square root of t squared plus 8 raised to the 12th power. That looks like that's a lot of business to deal with. Really isn't. So that minus sign that's sitting out in front, that really has nothing, no bearing in the problem. Bring it down. It's understood 2 outside, so it's a square root. Now, t squared plus 8 raised to the 12th power. Please do not write that 12 times and multiply it out. Just don't. Take the exponents and divide them out. So that's t squared plus 8, 12 divided by 2 power. So that's t squared plus 8 raised to the 6th power. And that's your answer. That's simplified. That's done. You do not need to multiply it out. Move on about the rest of your day. Example 3. Now we have the fifth root, 1024 p to the 10th, q to the 35th power. So again, go ahead and separate it, which if you don't feel that you need to separate it, okay, then don't separate it. Just make sure you keep your parts together. Make sure you keep everything in order. The fifth root of 1024 means what to the fifth power will give you 1024? That's 4. That's 4. If you want to go do the computation, be my guest. Fifth root of p to the 10th, so that's 10 divided by 5, p squared. Fifth root of q to the 35th is q to the 35 divided by 5, q to the 7th power. And simplified. Everything simplified. So moving on to example. So example 4, we got negative 49 n to the 4th, n to the 2nd. So again, no number out in front means we're dealing with a square root. Separate everything. Square root of negative 49, m to the 4th, n squared, n to the 12th power. So square root of negative 49. I told you i's can still come into the problem. So the square root of negative 49 is 7i. M to the 4th. 2 goes into 4 twice, so m squared. 2 goes into 12 6 times, so n to the 6th power. So n to the 6th power. So again, since this is an even radical even index, we put plus or minus in front. Put plus or minus in front. Now, if you're wondering, why didn't we put plus or minus in front of 2, in front of example 2? Because there was already a minus sign sitting out there. So it's already indicating what sign it's going to take. So there you go. Example 5, 4th root of 256, c to the 16th power, d to the 8th power. So once again, separate everything. So 4th root of 256. So that's plus or minus 4. So remember, plus or minus only comes in when the index, the number outside, is even. If it's odd, you don't have to worry about it. 4 goes into 16 4 times, so c to the 4th. 8 twice, d to the 2nd. And that's simplified. And let's do one more before we add another wrinkle into this. 3rd root of negative 27, 2x plus 3 raised to the 6th power. So once again, we're going to go ahead and simplify and separate it. Clean that up a little bit. 2x plus 3 raised to the 6th power. So root of negative 27 is what raised to the 3rd power gives you negative 27. This time that is a negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3, negative 27. So the negative does matter. We do not put plus or minus because that is an odd index. So you got to keep in mind your odds and evens. 6, so that's 2x plus 3 squared. So navigating through those 6 examples, again, the numbers you treat as is, the variables or the expressions, you divide the exponents. You got to pay attention to the indices, plural form of x. If the index is odd, you don't know this is even, just put plus or minus in the answer. So those are questions 1 through 6. So there is one wrinkle that you need to keep in mind. So for radical problems in which you are dividing an even exponent by an even index and you get an odd result. So even index, so even divided by even and it gives you odd. What are we talking about here, Mr. O? Well, here's an example. 6 divided by 2 is 3. So how would this show itself up? You have an even exponent. There's x to the 6. You have an even index, and that leaves you with x to the 3rd. So if this situation occurs, then you put absolute value bars around your answer. The reason why you do that is to make sure that your answer does not pop off and become negative. So x to the 3rd, in this case, you would put absolute value bars around. So even exponent, even index, and you get an odd answer. So not overly difficult, just something you have to pay attention to. Now, that only goes around the variables. The numbers are fine. The numbers still work the way they work. So let's take a look at examples 7 and 8. So, case in point, square root of 36y to the 6. So that's square root 36, square root of y to the 6. So the square root of 36 is 6. So you still put your plus or minus 6. 2 goes into 6 3 times, so that's y to the 3rd, but then you put the absolute value around it. You put the absolute value bars around it. Remember, plus or minus comes in because it's an even index. Absolute value comes in because even exponent, even index, odd result. Yeah, not overly difficult, just something you have to keep in mind. And let's do another example of this type. So 4th root of 625, v plus 3 raised to the 12th power. So once again, I'm going to separate them. So the 4th root of 625 is 5. So plus or minus 5. 4 goes into 12 3 times. So v plus 3 raised to the 3rd power. Absolute value around the variable answer. It's just the variable answer, not around the number. The number is taken care of by the plus or minus. So only the variable answer needs to get treated a certain type of way. All right, so the last few examples, we're working with the calculator. How do we do this in terms of a calculator? Now, of course, I'm going to show you using the graphing calculator. Obviously, if you don't have a graphing calculator, you can use Desmos, etc. to help yourself out. So, problem 9, we have the cube root of 49. The cube root of 49. So, in the case of that particular problem, that one is actually fairly easy to navigate and to work with. So let me pull up my calculator here. So we're doing the third root of 49. Yes, third root of 49. So in a graphing calculator, go to Math. Notice that the fourth button down is for cube roots, third roots. So go ahead and press that. Type in your 49. There you go. 3.659,30571. So we weren't given any guidance as to where to round. In this particular case, let's go ahead and take this to 3 decimals. So we're at 3.659. So 3.659. So most of the time, they'll give you some guidance as to where to round. If they don't, use 3 decimal places. Now, that's for a cube root. Now, if you were paying attention to the calculator, when we go to Math, there is a button right up underneath the cube root that says X root. X root is for any other number other than the number 3. So 4, 5, 6, 12, 50, a billion, whatever it is you want to use. In this case, example 10 was a 5th root. Example 10 was the 5th root of negative 116. So what you'll do first, press the number 5 because you want the 5th root. Hit Math. Go down to the X root key. Notice that it puts the root up there for you. And then type in negative 116. And it gives you your value. So negative 2.588. Negative 2.588. All right, and last one, problem 11. The surface area of a sphere can be determined from the volume of the sphere using the formula S equals cube root of 36 pi v squared. V is the volume. Determine the surface area of a sphere with a volume of 200 cubic inches. So they're telling you in the problem that V is equal to 200. So more or less some basic plug and chug. 36 pi times 200 squared. So we can essentially throw this all in the calculator and let it do the work. So let's go to the calculator. Math. Cube root. 36 times second. Up arrow to get the pi. Parentheses. 200 squared. Notice that I literally threw everything into the calculator. As long as you type it in correctly, you can throw everything in the calculator. Press enter. 165.388 ends up being your surface area. 165.388. This is area, so that's square inches. There it is, and there you go. So with that, we're done with section 6.4. All of the written notes and this video will be uploaded to Google Classroom. You are now responsible for section 6.4. The next time we see each other, we'll discuss, take some questions. We're not going through the whole lesson again. As you can see, I am in the school building because you just heard the bell probably go off. So during this e-learning time, you are expected to watch the video, take the notes, come in asking questions, because you will be quizzed on it, assessed on it, and the homework will be due in its timely fashion. We're under an e-learning situation. It's not the ideal situation, but we're going to learn how to work through it. Life is about persevering. With that, have yourself a great rest of the day, and I'll talk to you soon.